Hello again. In this video we're going to be talking about the harmonic series. And a harmonic series is any series of the form written on the board, a series from 1 to infinity of 1 over n. And we know that every harmonic series is divergent. So, and like I said, it could be any series of this form. So here on the side I have an example problem, right? And then we can see that it's the same thing. We have n squared over 5n cubed, right? So if we cancel our n's out, it's the same thing as saying we have 1 over 5n cubed, or not cubed, excuse me. We have 1 over 5n, right? Because our n's cancel. And because this is a series, right, we have infinity, n equals 1. We can pull our 1/5 out in front. And we see that all we're left with is 1 over n. So any series that can be rewritten as 1 over n is a harmonic series. So you have to keep your eye out for things that could be of the form 1 over n. And I want to kind of just take a second and kind of help explain why we know that it's divergent. So one way we can kind of show that this is divergent is by kind of considering or looking at this as if it was a telescoping series for a second. So in our telescoping series, we started off in the last couple videos, or in some of our other videos, by identifying an n and just kind of writing out our partial sums, right? So we have Sn, we're going to say when n equals 1. So our partial sums for when n equals 1 is just going to be, you plug in 1 for n, so you just get 1. When n equals 2, you get 1 plus 1/2, right? Let's say if this was 3, you're going to add on a 1/3. So, and now let's say it was 4, right? And we're going to kind of make a comparison here. So you're going to add on your 1/4. So, like I said, we're going to be making a comparison with another argument. We know that 1/3, right? We're going to say 1/3 we know is greater than 1/4. So, because we know this, make a little more room because this is going to be a lot of work here. We can say that this guy, this whole series then, this partial sum, is going to be greater than if we added 1 plus 1/2 plus 1/4 and 1/4, right? Since we know that 1/3 is bigger than 1/4, this is what makes the argument true. And we know that this is a total, adds up to 1/2, right? So now if we keep doing some more partial sums, we'll keep, adding on, if you do an n equals 5, you'll add on a 1/5. n equals 6, you add on a 1/6. So if we skip ahead a couple, let's skip ahead to an n equals 8. We'll see that we'll have 1 plus 1/2 plus 1/3 plus 1/4, 1/5, 1/6, 1/7, and 1/8, right? And we already kind of made the argument before about this piece, right? Up here. And these two guys, you know that, how this relates to get our inequality, right? So here we're going to be doing the same thing. We made this argument. Now we're going to make an argument with these pieces, right? Once again, if you add up these pieces, you are going to get a number, a fraction. If you plug this into your calculator, right, or just solve it out, add them all together, all of these guys, that these two guys are greater than 1/2, that these guys are going to be greater than 1/2. So this whole argument right here, this whole partial sum, is still greater. It's going to be greater than, we had 1/2 plus 1/2 plus 1/2. We have 1/2 plus 1/2. And this 1/2 counts for the 2/4 here, this guy. And then if we add another 1/2, this piece will still be greater than 1/2. So this guy is concluded by this. So since we know that these guys are greater, we can kind of, in a way, make up a new series, I guess, as a way of explaining it. If we were to look at the series from infinity oh, you can't see that. Hold on, I'll go up here. If we look at the series from infinity, n equals 1, we have a 1 here, and then for every time we're adding on some n over 2, right? We're adding on 1, 2, 3, so, that's 3 over 2, right? If you look at if you take the limit of this guy, we'll see of this guy right here. You plug in your infinity. You have infinity over 2 plus 1. That's just infinity, which means that this guy is divergent. And this guy is kind of explaining this pattern that we see here, right? So if this guy is divergent, and we know that this guy is greater than, or excuse me, is less than this guy, right here, this series. If we look at our comparison test, our work for our comparison test, our known series is divergent. It's less, the series is less than this one. We can conclude that, therefore, the harmonic series is also divergent.